Hello, we're going to take a look at wiring diagrams. If you're familiar with the diagnostic hub, you'll already know that there is a wiring diagrams area available from there. It's important to understand though that a different set of diagrams that are specific to the vehicle system selected can be found from within Troubleshooting. It's in this video you'll be learning how to access and understand these diagrams, looking at how they'll benefit your diagnostic routine. Wiring diagrams are often essential to an efficient diagnostic process. Feared by many, with some understanding and a little practice, you can soon have an intimate understanding of their layout, navigation and symbols. This familiarity can often be the key to shortening your diagnostic routine. Let's get started. From the section Selection Options, highlight Terminal Diagram and progress with Continue. You're now shown a wiring diagram on the right with the component key to the left. Looking to the top right of the display, we're shown that this is the first of 11 pages for this system. Okay, we've got a diagram displayed, but why would I want to use one? It may be that I'm very familiar with diagnostic repairs and I'll use the diagram to familiarise myself with the system. I may need to check wiring integrity and this will tell me which wires to check. Or I might just want to find which fuse feeds a particular component. Let's go back to the diagram and take a step-by-step look at its construction. Each diagram has the same foundations. We'll start with terminal 30. Terminal 30 is the constant battery positive. I'll add to that terminal 15, which is the switched ignition supply. At the bottom of the diagram is terminal 31, and that's our ground. To this we'll add some components. A6.6 is the central electronics control unit. All control units start with the letter A. Integral to this we have fuses, and a fuse always starts with the letter F. Beneath this we have A6.119, which is the access authorization control unit, and beside that A4.1, the airbag control unit. A4.1 has a break in the centre and on the right hand edge, showing that not all of the control unit is on this page. Below access authorization you have A6.31, the phone transmitter receiver, and X19.3 being a connector block. All connectors are shown with the letter X. Last but not least we have A6.25, which is the roof control unit, and integral to that H3.5, which is an indicator lamp for the front passenger airbag. Each of the control units is labelled with pin numbers. The last items to add are the wires to join it all together. So there you go. If we take each diagram step by step, you can start to piece the jigsaw together, and before you'll know it, you'll not only understand what each component is, but how they're all connected together. But what about using a wiring diagram as part of your diagnostic routine? Let's take a quick look at a scenario where the warning lamp for the passenger's airbag isn't working. For the warning lamp to work, a power supply needs to be applied. It requires a positive supply on pin 3 of the roof control unit and a ground at pin 7. The positive supply comes from terminal 15, through the fuses and into the roof controller, then on internally to the lamp. Its ground comes from terminal 31 to the airbag control unit. The airbag control unit has an internal transistor. This acts as a switch. When the switch is closed by the control unit, the ground is applied to pin 7 of the roof controller and subsequently the lamp. Hey presto, and the lamp comes on. Now that you know how to interpret the diagram, you can start to make your own diagnostic checklists. It might go something like this. Can I turn on the lamp via actuators using the ET750? If actuated but not illuminated, check the power supply at pin 3 and 7 of the roof control unit. If no power, then the fault is on the positive supply or ground. If it's the ground, then is the problem with the wiring or the airbag control unit? If you decided to check the ground wiring, you'd need to identify which pin on the control unit was responsible for that. We can see that it's pin B43. You'll then need to find that pin on the control unit plug. That's a straightforward process. Just minimise the diagram, select Continue until the control unit connector is displayed, and maximise for easier viewing. You can now see which is plug A and B. The pin numbers are also shown, and here is pin B43. This is just an example of how being able to interpret a wiring diagram will enable you to ask better diagnostic questions. From there, you can do the most important part of any diagnostic routine, which is to carry out the tests and keep on testing until you find the fault. Okay, so you now know why to use a wiring diagram and how to interpret it. But what about navigation? This diagram has more than one page. You'll come across this situation where two components are joined and you have to navigate the pages to find the relevant information. This is the reason for the numbers along the bottom of the diagram. They're used in conjunction with the component references, like this one here. In this instance, we're told that component X9.2 is joined to this wire. To find where it goes, I need to locate position 85 from the numbers along the bottom. To do that, I'll minimise the diagram and select Continue until I find position 85. I can now enlarge the diagram once more, follow directly upwards from position 85 to see that the wire goes to pin 16 of the diagnostic socket. It's the positive supply. To navigate in reverse direction, I'm shown that this wire goes to component F6.2 at position 15. Finding position 15 in the same manner as before takes you back to our first diagram. Following the wire shows it coming from fuse 6.2. Okay, so now you understand the component parts of a wiring diagram, how to navigate them and where you could use them. Don't forget that although we've taken a look at the airbag system, the ET750 has this kind of information for an awful lot of other systems. Thanks for watching.